Let's take a moment to talk about valves in irrigation systems. In the simplest terms possible, a valve is just a device that turns the water on and off. It allows the water to flow, or it stops the water from flowing. And this is what turns the sprinklers on and turns the sprinklers off. There are two general categories of valves. And the first type are the manual valves. So those are things you turn on with your hands. They have no electricity. There's no automatic element to them. And an example of that would be a hose bib or a faucet, a spigot that you turn in order to turn the water on. That specific valve is called a gate valve because as you turn the handle, a gate will rise and allow the water to flow through. When you tighten the handle, the gate will close and the flow will stop. We also have ball valves, and a ball valve is just a quarter turn and it rotates a ball inside the pipe that either stops the flow or allows the flow to pass. Now on an irrigation system, a lot of times we call those isolation valves because we use them in order to isolate different parts of the irrigation system. So if you ever needed to do maintenance or you had a repair that needed to be done, you could isolate different parts of the sprinkler system so the water wouldn't flow when you didn't want it to. But what we're really going to talk about today are automatic control valves. And so that's this device here. And you can see it's got electrical wires because this operates with electricity. So let's talk about this. We'll discuss how it works. We'll take it apart, put it back together, and you'll have somewhat of a better understanding of how this very sophisticated device works after we do that. This valve here is called a globe valve. The way we know that is because this is in line with the pipes. So what that means is this is meant to be down underground and sitting at the same level as our main line and then our lateral line after the valve. Here's another type of valve. This is called an anti-siphon valve. And look at the orientation of the pipe. So we have water coming up, and actually it goes this way. We have water coming up, going through the valve, and then coming back down. And as it does, here's our angle valve, and attached to that is an anti-siphon device. This prevents water from ever flowing backwards through the pipe. So this is what you would use on a larger system where you had a backflow device on the entire irrigation system. And all of these can be underground where they're a little bit more protected, less likely to get damaged, and there's fewer working parts, they're a little bit cheaper. On a residential system, though, it's rare that you would have a backflow device because that's a big, expensive feature that needs its own maintenance. Usually, if you only have a few valves on an irrigation system, you prevent your backflow with an anti-siphon valve. Now, the only thing is, this needs to be physically higher in elevation than any other pop-up on your system, and at least a foot higher. So oftentimes you see these up higher than ground level, and you have water coming in, water coming out, and then if there's ever a back pull in pressure from the city main line, if somebody runs over a fire hydrant, for example, and it pulls the water out of your sprinkler system, this little device here will break the vacuum that allows water to be pulled. And so for these, this is residential, this is commercial, but today we're just going to be focusing on the automatic control valve. And for simplicity's sake, we'll take a look at this one. So these come in various materials and sizes. This is 1 inch. So that refers to the diameter of pipe going in and out, 1 inch. And it's threaded, so you can have either threaded or slip valves. This is made of plastic, a durable plastic. You can also get them made of bronze or brass, but those are more expensive. Those you typically see on public parks, golf courses, things like that. Plastic is cheaper. It's a little bit less durable, but it does resist corrosion, and it's kind of the standard for the irrigation industry. Notice how we've got this piece sticking up here, and it's on one side. So this is not symmetrical, meaning it's not really meant to be interchangeable. There's a proper orientation for this to be installed, and you can tell the orientation by looking at the arrow. I've painted it silver. Normally it's just the same color as the plastic, but you can see the water flow is meant to go in this direction. So more than anything, that's the first thing you check out, is what's the proper orientation. If you stuck it in this way and you had your water flowing like so, it simply would not work. So they need to be installed in the proper orientation. And the way to do that is to make sure this device here, called the solenoid needs to be on the downstream side. And just check out those arrows to double check and make sure you've got it oriented properly. So here we have a cutaway valve, and we can use it to see what's happening inside when this electricity causes water to start and stop flowing. It's quite sophisticated and takes a little bit of understanding to realize how it works. But it's important to know how it works so we can make sure it operates properly, and if it's ever broken, that we know how to fix it. So we'll talk about some terminology. First of all, with our valve, we've got the body. So the place that holds the pipes coming in, the plastic or brass, bronze, actual outside of the valve's called the body. And on top, this piece here is called the bonnet. So we have a body, we have a bonnet. Those two pieces are attached. That's what holds everything inside together. And it also holds the water pressure, which enables this to operate. So this is more than just the container. This piece is actually part of the internal functioning of the valve. Now, if we turn this around to look inside the valve, we've got this rubber piece here, this soft piece, this flap. This is called the diaphragm. And this is what actually does the opening and closing. And then attached to that is a spring, and that's the diaphragm spring. As I mentioned already, this piece here is the solenoid with the wires attached. And down here, there's an element that is actually missing on this valve. It's a little metal piece that goes down in this channel, and that is called the solenoid plunger. So the plunger goes up and down as electricity is applied, and it causes magnets to either pull the plunger up or to drop and release this little metal piece. And in some ways, that's the magic of it all. This little metal pin going up and down that changes the nature of the valve. So what's actually happening when this valve is operating? It would take a lot of force to just plug up the water. We know there can be a lot of pressure in the pipes, and a lot of water will move through those pipes. So that would cause wear and tear, and we want something that's going to be minimal force, minimal pressure. And so how this works is it actually uses the water coming in to stop itself. So as water's flowing into the valve, it is flowing in and then coming up against this diaphragm on the bottom. And you see how the space here is only a certain width, and that size here is less than the size up here. Do you see how the top chamber is wider than the bottom chamber? So that's how this works. We have water coming in, pushing up, but we also have the ability for water to come up into here, but it still has nowhere to go. And because it has the same amount of pressure, it pushes down. And because it's larger on this side than it is on this side, the force pushing down is greater than the force pushing up. So the water coming in is what stops the water from continuing. But then how do we ever cause that to change? Well, when the water flows into this top chamber, it also comes up to the solenoid, and we have the plunger down here. When electricity triggers the solenoid and the plunger is pulled up, the water up here drains down and out. And as this diminishes, this pressure becomes stronger than what's pushing down, and the diaphragm can open, causing all the water to flow freely through the valve. When the electricity stops and the plunger drops, it prevents the water from flowing out of this little chamber, and then slowly, as water is passing, it will start to fill the top of the diaphragm, and once the weight on top is greater than the weight coming through, the plunger drops with the force of this spring. And so it's a way for the force of water to stop itself, all with the raising and lowering of a tiny little pin caused by 24 volts, low voltage electricity. So it's a relatively efficient way to automatically turn on and off water. If you didn't do it this way and you were literally stopping 100% of the force, your components would wear out more quickly and you would need more energy in order to fight all of that water with all of its pressure and movement. So this uses the water against itself to stop and start it. It's very sophisticated and it's kind of tricky in how it works, a little bit counterintuitive. This is why they need to be installed with the proper orientation. If you put them this way and the water comes in, it just literally doesn't work. It needs to be that the flow of water can stop itself with the direction coming in. So there's a few other pieces here on your 1-inch valve. We know about the solenoid. This middle knob is the flow control handle, and this can be turned in order to increase or decrease the pressure of the spring pushing down. And that's really only something that needs to be adjusted one time once the valve is installed. Basically, this controls how high or low the diaphragm goes when the valve is open, and adjusting it enables the valve to turn off more quickly or more slowly. And if it closes too slowly, it may not close at all. And so it needs to be fine-tuned so that it matches the amount of water flowing through a system. This other knob here is your bleed screw. And if you want to flush out a valve, like say there's debris in here and you don't want to take it all apart, there's this opening here that as water's coming in will shoot out from the bleed screw, and this enables you to flush out and clean out a valve. This will also cause the valve to open. Now, sometimes people use this to manually turn on and off a valve, but if you do that, there's a chance you can wear out the threads easily, and also there's a chance that it may not close properly because this is changing the pressure inside of here drastically. The far better way to manually turn on a valve is to look at the solenoid itself, and if you do a quarter turn, that is enough to allow the valve to manually open the way it's supposed to open, and then you do your quarter turn to close, and that lets the valve engage and stop operating, and it prolongs the life of your valve. It also doesn't leak any water into the valve box, so it's much better when you're testing out a system, or if you want to manually open or close, use the solenoid instead of the bleed screw. You use the bleed screw when you want to clean out the valve. So like our other assignments in this class, we're going to do a breakdown of all the parts. We're going to label them, and then we're going to reassemble the valve. This is the best way for you to really understand what's inside and how it works. Now, the only tool you're going to need is a screwdriver. It could be a Phillips screwdriver or a flat head screwdriver, or you could even have a wrench. Now, there's many different ways to get this open, but you will need a tool that enables you to open these 4 screws. So what I'm going to do first is I'm going to remove the solenoid. I recommend putting these down on a sheet of paper or something clean so you'll be able to reassemble all of this properly without causing anything to have any damage or anything. Take off the bleed screw. So when we take off the bonnet, you may want a long handle screwdriver because these are in a bit tight, and just be careful. Take your time. It's probably best to rotate around as you go. And you want to get them loose without stripping the screw or causing too much damage. But with a little bit of patience, you should be able to get this open. Just be careful that you don't end up slipping and hurting yourself here. Find a good, comfortable position that enables you to open these up in a timely way. A little short screwdriver, you have less force to open with, but it also gets the job done. So when you get these screws out of here, pull them all out, lay them down on your sheet of paper for your integrated parts breakdown. And now we can pull off the bonnet. Now if we take a look at this bonnet, underneath you'll see the diaphragm. And this piece may feel like it's attached pretty firmly. And if you push, you may not necessarily feel any amount that it can go in or out. So what we need to do is loosen this flow control handle. If you turn this several times, you'll actually have the spring engaging more. And you can actually see water coming out. That's from when they test the valve to make sure it works. So there's still some water in here from the factory, but you can see the valve in operation. Now if you pull out this little tab, you should be able to remove the diaphragm. You can see that it is still wet from the factory test. So we'll set this down, and then here is our diaphragm spring, and then this piece just stays like so. Now if we take a look at this diaphragm, notice the small holes here. This is what enables the water to come up past the diaphragm. And remember, it's the force of the water itself that will keep it closed against the rest of it pushing up. And you can see a tiny hole in here, and that's how the water enters the top chamber of the valve. And then if you look down here, you can see the diaphragm seat. This is what rests at the bottom of the diaphragm. And then, so this is the force competing from the bottom with the force from the top. And so that diaphragm seat just sits right in here. And as water comes in, it's pushing up against the diaphragm, but it's also going through the diaphragm and pushing down against the diaphragm. And because this area is wider than this area, we have a greater force on top and a smaller force on the bottom, but it's coming from the same direction and the same water. Very interesting. So take out the diaphragm seat, and then here we've got our sprinkler body. So we want to lay all those out on paper, take a picture, label all the components, and that's going to be your integrated parts breakdown. And then you need to put it all back together again. So it all needs to go in the proper order. Go ahead and attach your diaphragm seat. Attach your diaphragm spring. Make sure this is oriented properly. there's the hole here that acts as a guide, as well as the hole here. You line up these two holes, and that's where this tab goes on your diaphragm. So that fits in just like so. And you orient it properly by making sure the tab lines up. There we are. And you can tighten down your flow control. If you put it too tight, it may be difficult to screw this back together. Then we take our screws and we put them back in. When you're putting these screws back in, you'll get to where it's tight once again. Just go slow, apply pressure, but make sure you're safe and cautious. Don't allow the tool to slip and hurt your hand. You can make sure this is not too tight. If you have this cranked down too tight, it may resist closing a little bit. And like I said, you rotate from screw to screw and get it in there. And eventually you'll get it all tightened down with no issues. So there we go, all 4 screws are in there and in there good. Put your flow control back in. You take your solenoid and that goes back in as well. Be a little bit careful, these are small threads, so make sure the threads are lined up. And there we go. We've got our valve back in operation and ready for action. So let's say you're looking at an irrigation system, someone calls you up and the valve is not working and you need to figure out what's wrong. Well, there's many things that can be wrong, but there's not an infinite number of things that can go wrong. And so here's what you do to check to make sure the valve is working properly. And before you jump to the conclusion that it's the trickiest, most technical thing that requires expensive replacing of parts or manual labor, do the easy things first. So no matter what anyone tells you, if you're going to do an inspection, you do the checks. Don't trust anybody. So first, go and make sure every valve is open. At the point of connection, at the water meter, at the backflow device, are there any isolation valves that are closed and causing this thing to not work? Because sometimes all that's wrong is you just got to go and turn the water on. The water's been turned off somewhere else. Make sure that water is flowing to the valve. Next, you want to make sure that this flow control is not all the way down. If the flow control is all the way down, the spring and the screw in here will not let the diaphragm rise. And so this thing should not be all the way closed. Sometimes people will do that to turn off a valve if they're not necessarily informed or if they're just trying to fix an immediate problem. So open this up because this is supposed to be able to flow. So that's the second thing you check. The third thing you check, or maybe the second thing you check, is make sure this isn't installed backwards. It can happen. It can very easily happen. So if this was installed backwards, it's not going to work. So that's an easy fix. That's something that is very different than any other type of fix. So before you open this up or take it apart or buy a new one, make sure it's operating the way it should be and that some of these control features are not engaged. So now if our problem persists and the valve will not open, we need to take a look at this diaphragm. And the nice thing is you can keep the valve in line and simply undo the screws and take a look at that diaphragm. We want to inspect several things. First, we want to see, is the diaphragm installed properly? If someone had done a repair on this valve, there's a chance they could have it flipped upside down or backwards, and then water will not be able to flow through the diaphragm in the way that it needs to in order to enable it to open. So make sure the diaphragm is oriented properly. And then you want to inspect the diaphragm itself. It is a softer piece that could wear out. So you want to make sure there's no pinholes in there or any kind of shredded material that then allows water to flow more than it's supposed to. So make sure the diaphragm is still in good condition. It's very cheap and easy to replace just the diaphragm, much cheaper than replacing the whole valve. The next thing you want to inspect is the solenoid, in particular the solenoid tube. So the little plunger that's in here, it can get bent. And if the plunger is bent, or if the tube is somehow bent, then that won't enable the plunger to rise and fall. So oftentimes you'll keep a little piece of wire or something in your kit and just push that down into the solenoid tube to verify that that tube is free of debris and that it's not bent or crooked or blocking anything that is preventing the solenoid from operating. Additionally, there's the outlet port, and that's where the water flows through the valve. You want to make sure all those little holes and ports are not clogged. So again, those wires, pipe cleaners, little tiny things to just make sure there's no debris in here. And if you do all that, then the valve should turn on. It should operate normally. Now let's talk about what to do if the valve does not close. If the valve is staying open and it won't close, something is preventing the water from accumulating on top of the diaphragm and then pushing it down. So it's either not making enough pressure up here, or it's not holding the pressure for long enough to allow the diaphragm to close. One thing that may be happening is the solenoid and the plunger is obstructed, but in the reverse way as before. But there can be a little sand grain or a piece in here, so you want to open this up and make sure you've cleaned it out. Many times, if you are in ground and you open this up to do a repair, you could potentially get some rocks or debris falling from the top down into the valve, and you can get a small rock or a piece of sand lodging on that diaphragm seat or the valve seat. So when the diaphragm closes, it won't make a good seal. So verify that the white part, the seat, is clean and clear of debris, and that the diaphragm is actually able to lower down in the closed position. The other thing you may want to do, remember, this is not just the outside case, but this holds the pressure. So the sprinkler body and the bonnet need to be attached properly. These screws need to be all the way down, and they should have equal torque. So if one is very tight and a few others are loose, that can cause this to be slightly maladjusted, and then you won't have the proper opening above the diaphragm. So make sure as this is closed, everything's down with equal levels of tightness or torque, so that you've got a good chamber above your diaphragm. It could also be the case that your inlet port is blocked, or perhaps your bleed screw is not all the way down, and so you're not able to build the top pressure here. It could also be the case that if you have a valve that's too big for the system, or that your water pressure is really high, an improperly sized valve will not have enough friction or pressure loss for the thing to operate properly. So in this case, you can close the flow control, which in effect kind of makes it operate like a smaller valve. So you should turn the flow control down until you observe some of the high pressure in your sprinklers, like if there's misting or fogging at the emitter. Turn this down until that diminishes, and then your valve may very well operate properly when the pressure is restricted, and then it acts like it's at the right size. So ultimately, there's all sorts of delicate tolerances that are needing to be met in order for a valve to operate properly. It's a very simple device, and yet it's quite sophisticated in its operation. It can be very counterintuitive. If you don't understand how it works, you'll scratch your head looking at it saying, I have no clue how to operate or fix this thing. And so once you understand its operation and its component parts, you'll be much more equipped to be able to address any failures in an irrigation system and you'll install them better too. So here we have an automatic control valve, very impressive device, a little engineering masterpiece, and a very simple and efficient way to turn your sprinklers on and off in the landscape.